Hey guys, today we are going to review Chapter 4 and we'll do this in 2 videos. So in this video we will solve a polynomial equation with a degree greater than 2, and then we will write a couple of polynomial equations with a degree greater than 2. So first we're going to solve this equation using the rational root theorem. So first, how many complex roots are there? Complex roots could be real or imaginary. We look for the degree. It's right here. The degree is 4. So there are 4 complex roots for this equation. Okay, so now using the rational root theorem, we will find all of the 4 roots and give them inexact answers. Okay, so first, let's find all of the q's. Q is plus or minus the set that includes all the factors of 3, and those factors are 1 and 3. Then P is all the factors of 7, so plus or minus all the factors of 7, that's 1 and 7. Okay, so now P over Q, so P over Q equals plus or minus the set of all the P's over all the Q's, so 1 over 1, 7 over 1, 1 over 3, 7 over 3. So there's all the P's over all the Q's. Okay? Now these are all the possible rational roots. Okay? So it's possible that all 4 of these are the roots and that's it, and then we're done. Okay? It's possible that maybe just a couple of them are. So we will graph. So we'll start by graphing the equation and see what we can see in the graph. Okay, so there's our equation, and here is the graph. And I see 2 intersections. Let's zoom in a little bit. So I'll go with zoom 4 just to get a little nicer view. Okay, so these 2 may show up in our list here. This one looks like it would be -1. Okay, so it's plus or minus any of these options. So we'll go with the -1. So let's trace -1. And if -1 really is a root, then it's an x-intercept, so the y value, the output, will be 0, and it is. Okay, so I know that x equals -1, so there is one of my 4 roots. Okay, so then this one right here looks like it could be 1/3, so we'll trace 1/3. And the output there is also 0, so 1/3 is one of my 4 roots. And it looks like that's all I will get from the graph. Okay, so our next move is to use synthetic division. Okay, so I'll put -1 outside. I'll use the -1 first to deal with fractions later instead of dealing with fractions right from the beginning. So -1 outside. Okay. And then I have 3, 11, 26, 11, -7 inside. Okay, so I start my division by bringing down the 3, and then I multiply and add until I get all the way through. And in the end, I really need to have a remainder here of 0 if I did this correctly. Okay, so multiply, and I get -3, add, and I get 8, multiply, -8, add, 18, multiply, -18, add, -7, multiply, 7, add, 0. So I got a remainder of 0, so I know that my root of -1 was correct. Okay, now I'm going to do this again with 1/3. So I'll bring down this 3 and multiply. 1/3 times 3 is 1, add, and I get 9. Multiply, and I get 3, add, and I get 21. Multiply, and I get 7, add, and I get a remainder of 0 again. Okay, so I know that both of my roots were correct because they divided in without remainders. Okay, so now I have 3x squared plus 9x plus 21, and I set that equal to 0 and solve. So now I'm just dealing with a quadratic equation, and I can solve by factoring, completing the square, or using the quadratic formula. I think this will be easier if I simplify my numbers by dividing both sides by 3. I get x squared plus 3x plus 7 equals 0. Okay? Now, numbers that multiply to 7 and add to 3, I don't think those exist, so I'm not going to be able to factor this. So I can complete the square or use the quadratic formula. Let's use the quadratic formula. X equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, and then I get negative 3 plus or minus the square root of, and we can use the calculator for this, 3 squared minus 4 times 1 times 7 is negative 27. And I see I made a mistake there. I did 3, and then instead of squared, I hit x. So I actually need to do that again. 3 squared minus 4 times 1 times 7 is negative 19. So I'll scratch that out, and I've got negative 19 there. Okay, all over 2 times a, so that's 2 times 1, which is 2. Okay, so this represents 2 different solutions because there's a plus or minus there. And I'm going to split this up into 2 separate fractions. Negative 3 halves plus or minus the square root of, and then negative 19 is really I times the square root of 19 over 2. So when I have a negative under a radical, I want to do the square root of negative 1, which is I. So my final 2 solutions are negative 3 halves plus or minus I times the square root of 19 over 2. So there's my 4 roots, and this represents 2, one with a plus, one with a minus. Okay, now we're going to write a polynomial equation given the roots. Now, if 7 is a root of an equation, that means one of the factors is x minus 7. And then one of the factors is x minus 5i, and the other factor is x plus 5i. Okay, and those are the factors when set equal to 0. Okay, so now I want to multiply these. When I have imaginary parts, I want to multiply those first. So I'll leave the x minus 7 as is, and then I get x squared plus 5ix minus 5ix, so those cancel, and then minus 25i squared equals 0. Okay, now I squared is negative 1. So it's really negative 25 times negative 1. So I have x minus 7 times x squared plus 25 equals 0. And I can distribute this. So I have x cubed plus 25x minus 7x squared. And then negative 7 times 25 is negative 175. Okay, now I really want to change the order so that the powers are in descending order. So x cubed minus 7x squared plus 25x minus 175 equals 0. Okay, so if 9 is a root for this equation, then one of the factors is x minus 9, one factor is x minus 6, and the other factor is x minus 1/3 when set equal to 0. Okay, I will deal with the fraction at the end, so I'll do these two first. So I have x squared minus 6x minus 9x, that's minus 15x, plus, and then 9 times 6 is 54. Okay, so now I'll distribute this x minus 1/3, so I've got x cubed minus 15x squared plus 54x, and then I'll distribute the negative 1/3, so minus 1/3 x squared. Okay, then negative 1/3 times negative 15x is positive 5x, and then 1/3 of 54, so 54 divided by negative 3 is negative 18. Okay, now in order to get rid of this fraction, I'm going to multiply this entire thing by 3. So I have 3x cubed minus 45x squared plus 162x, and then minus x squared plus 15x minus 54 equals 0. And now I'll combine like terms and put this in descending order. So I have 3x cubed, then negative 45x squared minus x squared is negative 46x squared. 162x plus 15x is 177x minus 54 equals 0.